Okay, good afternoon, everyone. Yesterday we had already solved one question, and I've given you an assignment, and many of you solved the question, solved the assignment, and send it to my inbox. I really appreciate those students who had done the assignment. So today we are going to solve another question, and later I'm going to give you two assignments similar to the question that we're going to solve today. So our question for today is given on the board. Let me go through the question first. The pilot of an aeroplane observes that the angle of depression of a kilometer stone on a straight road on horizontal ground is 30 degrees when his aeroplane is at a particular altitude. When he increases the altitude by 300 meters, the angle of depression of the next kilometer stone is 60 degrees. Find the altitude of the aeroplane when the first observation was made. So let's start by drawing a diagram. So we need to know the position of the aeroplane. So first of all, let's assume that this is the position of the aeroplane. Then if this is the position of the aeroplane in the first position, on the horizontal ground is 30 degrees, the angle of depression of a kilometer stone. So the kilometer stone is somewhere here. So this is the kilometer stone, and from that position the angle of depression of the kilometer stone, which is here, is 30 degrees. Now when he increases the altitude by 300 meters, so the position of the aeroplane now increases by 300 meters. So this is 300 meters. Now the aeroplane is actually here. Let's see the question again. The angle of depression of the next kilometer stone. So this was the first kilometer stone. So the next kilometer stone, let's assume that it is here. Now on increasing the height of the aeroplane by 300 meters, the depression of the next kilometer stone is given to be 60 degrees. So this is 60 degrees. This point and this point are the positions of the aeroplane. This was the initial position when the angle of depression was 30 degrees, and on increasing the height of the aeroplane by 300 meters, the next kilometer stone, the angle of depression of the next kilometer stone from that position is 60 degrees. So we need to be very clear. You need to be very clear about the question, and the diagram needs to be correct. Now another thing which is very important is this point, this distance. So this distance, this is a kilometer stone, this is a kilometer stone. So the distance between two kilometer stone would automatically be 1 kilometer, which is 1000 meters. So let's give the name A, B, C, D, then E. Now A and D are the position of the aeroplane. So let's write what we have. Let A and D be the positions of the aeroplane. Now let us write the rest of the given. Angle AEB equal to 60 degrees. Angle ACB equal to 30 degrees. AD is given to be 300 meters. Then again CE So C and E are the positions of the kilometer stones. Therefore, the distance between C and E will be 1 kilometer, which is 1000 meters. And we are to find the height of the aeroplane when the first observation was made. So that is BD. So let's write BD. We have to find this value. Now let's start with the first right angle triangle. Let's take the right angle triangle ABE. In right angle triangle ABE, right angle at B. So tan 60 degree equal to AB by BE. AB by BE. So tan 60 degree is √3. Then AB can be written as AD plus BD, then BE by BE. So let's cross multiply. So this will be BE √3 equal to AD. Looking at AD, the value of AD is given to be 300 plus BD. So BE equal to 300 plus BD by √3. So this is equation 1. So we have the first equation. Then now let's take the other right angle triangle. In right angle triangle DBC, right angled at B, tan 30 degree equal to BD by BC. BD by BC. So whenever you have a combination of figures like this, you can always separate the figure for you to solve, to make the solution a lot easier. So assume that this is A, B, E. Then again, here the angle is 60 degree, and just separate the figure D, B, C. This is 30 degree. So when you separate the figure, taking the side, you won't make a mistake in taking the sides. So tan 30 degree. So what is the value of tan 30 degree? Tan 30 degree is 1 by √3 equal to BD. Now let's look at BC. So this BC can be written as CE plus BE. CE plus EB. Now let's cross multiply. So CE plus EB equal to BD √3. Now look at CE. So the value of CE, we have it as 1000 meters. So let's write 1000 plus EB. Now here we have BE. So this EB and BE should be same. So let's put the value from equation 1. 300 plus BD by √3 equal to BD √3. Now let's transfer the term that involves BD to the right hand side. So 1000 equal to BD √3 minus 300 plus BD by √3. So we need to solve the right hand side. So taking the LCM, which is √3. So √3 into √3 will be 3. So 3 2BD minus 300. Now you need to be careful with the sign here, because this minus has to be multiplied with 300 as well as the plus that we have here. So the BD would become minus BD. Here it is plus BD, but on opening the bracket or on multiplying this minus to both the values, both will become minus. Let's cross multiply again. So this is 1000 root 3 equal to 3BD minus BD would be 2BD minus 300. I'm going to continue on this side. So now I'm going to transfer this 300 to the left hand side and take the value of root 3, which is 1.73. So 1000 into 1.73, this is minus 300 here. So when you transfer it to the left hand side, it becomes plus 300 equal to 2BD. So on multiplying, this would become 1730 plus 300 equal to 2BD. So I'm going to simplify this and write 2BD on this side, and on addition this value would be 0302. So 2030. Then BD equal to 2030 by 2. So BD equal to, therefore BD equal to, cancel it, 102115 meters. So this is the answer, the height of the aeroplane in the first instance, or when the first observation was made. So you write the conclusion. Therefore, the altitude of the aeroplane in the when the first observation was made is 1015 meters. So this is how you conclude the solution. So go through the solution at any point or at any part. If there's any part that you find difficult to understand, you may ask me through the WhatsApp group, or you may inbox me directly. And I'm going to give you 2 assignments today, and I expect both the assignments, the solution of both the assignments by before 4 o'clock. So that will be all for today. We cannot do too many questions using the video because it's a bit difficult, but even then, if you put in enough effort from your side, this will work very well for you. So thank you for today.